Once we are done with the DC analysis, now we go for the AC equivalent circuit. Now the steps to be followed, steps for AC equivalent. Now step 2, we have done step 1 for DC. For step 2, what we will do, draw the circuit under AC operating conditions. Now what are AC operating conditions? What were the DC operating conditions? We were removing all AC sources and we are open circuiting the capacitance. Now in this, what we will do, we will remove all DC sources, we will short circuit the capacitors. Now what will happen to the capacitor? If you look at the diagram, this capacitor CC1 will be short circuited, this will be short circuited, and CC2 will be short circuited, and the DC source will be grounded. Now how the circuit will look like in this case? So you can see over here the circuit of in the AC operating condition, your DC source is replaced with a ground. This capacitor over here CC2 is short circuited, capacitance which was here is short circuited, your CE capacitor is short circuited. So this resistance will become redundant, and what we will have in this case, the emitter is nothing but a single ground, because this RE resistance will be redundant in this case. Now what you can see over here, R1 and R2 are like this. R1, one terminal connected to ground, R2 second terminal connected to ground, this is connected to base, this is your R1 and R2. Now this circuit can be replaced with a single resistance RTH, which is R1 parallel to R2, which is connected to, you can say this is connected to base, other terminal is grounded, so between base and ground you will have RTH in R1 parallel to R2. This is how the circuit can be reduced. So this circuit you should understand how it is drawn under AC operating condition, then it is very simple to replace it with an hybrid pi equivalent circuit. Now coming to the equivalent circuit, you can see here RTH is connected between base and ground, right? In emitter you don't have any resistance, you have RC between the collector and the ground, RS and Vin. This is the circuit under AC operating condition. Now what you can do in this, once you have drawn the circuit under AC operating condition, just replace the transistor with its hybrid pi equivalent. That means what will change in the diagram is only the transistor part, rest all the resistance, voltage, RC, other resistance will remain as it is. Similarly, I am drawing the AC equivalent for the problem also. You have same diagram for the problem, so the circuit will remain as it is for the analysis also. Now to the hybrid pi equivalent model. Now when you look at this, what has been done, only the transistor which was between base, emitter and collector is replaced with an hybrid pi equivalent. This is only the change in the circuit, so there is nothing difficult, and you can say the resistance RO has been included over here. So if RO is included, that means VA is specified in the question. So in the question VA is given as 100 volt. If the early voltage is specified in the question, then only you need to draw the RO. Why? The hybrid pi equivalent doesn't contain RO until and unless early voltage is specified. RO is nothing but the early voltage resistance which comes in the output side, so small RO. So wherever you have small RO, those are the AC resistances. Capital R suffix capital S, R suffix TH are nothing but the DC resistances. So we call this as an AC equivalent model. You can see in the diagram, R pi is between base and emitter and towards the base. GMV pi, direction is of the IC, collector current. You know IB, suppose IB is flowing in this direction, IE is flowing in this direction. You know IE is nothing but IB plus IC, that means IC should flow towards the transistor, hence it is shown in the diagram, IC is flowing into the transistor, IB is flowing into the transistor, and I is flowing out of the transistor. So this is the flow of the current, that is direction of the current. Voltage across R pi is shown as V pi, VI is across RTH, right? Now when you look at the diagram, voltage VI between these 2 points and voltage between these 2 points is nothing but the same, because you have parallel branch and voltage in the parallel branch is the same. So I can call this voltage also as VI, right? And I am finding output voltage between these 2 points. Since the diagram is same, I am using the other part also for explaining the concept. These are the values what are given in the question for the analysis, right?